So today we are going to see local sequence alignment in dynamic programming. As we have seen in the previous lecture, it was on global sequence alignment. We are also following the same formula, but there is a slight change. Here that is f of I comma j value is equal to maximum of 0 or the first or the second or the third value. Here the minus d is the gap penalty value. And suppose if you are going to fill the value for this cell, just like the previous case, here also we used to get the value from the vertical cell or this direction, that is horizontal direction, or from the diagonal direction, that is f of I minus 1 comma j minus 1 or plus s of x I yj value. Here also the entire program will be done in three different stages. The first one is initialization matrix construction, the second one is path matrix construction, and finally we have to trace back and get the alignments. Let us see the initialization matrix construction. Yeah, this is the typical initialization matrix. So here on top of this we have to write the first sequence like this, and the second sequence must be written from top to bottom like this, and here the values are collected from Blossom 50 standard matrix, and the gap penalty value, since we are using Blossom 50, it is always 8. So the boundary values are filled with 8 and the remaining cells are filled with the respective value. And the next stage is path matrix construction. So this is a typical path matrix table, and here always the I0, J0 value will be 0, and since we are using local sequence alignment, the gap penalty value is 8, and the only possibility of getting the value for this cell is horizontal side. Since 0 is here, 0 minus 8, and here the maximum is 0, so we are entering 0. And when we fill all the cell, here in the boundary condition is, or the boundary cells are always having 0. But in global sequence alignment, the boundary values are always negative. That you might have seen in the previous lecture. And here, when we fill all the cell, suppose when we see this, see H is aligned with H. So here, when we move up 0 minus 8, it is minus 8. And when we move horizontally, 0 minus 8, again minus 8. And when we move diagonally, already 0 is there. And the value for this cell is 10. 0 plus 10, the value is 10. So that is why we have given here. And the arrow is also pointing towards diagonally. When we come to this, when we move up, here the value for this cell is 0 minus 8 minus 8. This side, when we move 10 minus 8 plus 2, that is why we have given 2 here, and the arrow is pointing towards horizontal side. Like this, we have filled all the cell values, and once when the cell values are ready, we have to move the final stage. We have come to the last stage, that is the tracing back. This is a typical path matrix. So here we have filled all the values, that is right from this cell we have completed till this. When we have seen global sequence alignment, there the filling or the filling of the cell starts from this cell and always ends with this, and the tracing back will be from this to this corner. But here, since we are doing local sequence alignment, the tracing back will be starting from the highest value, that is a cell with highest value. And just like the previous case, based on the movement of the arrow, we have to give the gap either in the upper cell, upper string or the lower string. So here, the highest value is from this cell. Since it is the highest one, the starting of the tracing back will be from this. And since the arrow is pointing towards diagonal side, so here E from the upper string is aligned with the E from the second string. So here E with E. Once again it is moving diagonally. So H from the first one is aligned with another H. H with H. And here the movement is horizontal. So here naturally there will be a gap in the second string and the first string G is coming here. Once again it is moving diagonally. So here W is aligned with another W from the second string. Once again the move is diagonal and here A aligned with A and it is entering into 0. So we start with this, and this is the typical substring or the maximum aligned region. One more area is also having maximum aligned region. See, this is the maximum one. Here A is aligned with A, E aligned with E because it is a diagonal move, and H with H. So we have got two strings, that is a substrings having locally aligned region. So this is the typical local sequence alignment. When we compare local and global sequence alignment, see, in local sequence alignment the boundary values are always 0, but in the previous case global sequence alignment boundary values are always negative. And here the starting point of tracing back will be the cell with highest value, but there the starting point is this column. So with this the global sequence alignment program is completed. Thank you.